right, refocusing, please. Thank you. On the screen, you notice that I've drawn in those extra segments that are indicated with dashed lines. What I'd like you to notice about them is that now, in this circle, we have two triangles. Notice something about the two triangles. They have vertical angles that will be congruent. Notice also that this angle up here will be congruent to this angle because they're both inscribed angles and they're both intercepting the same arc. So what does that allow me to conclude about these triangles? If they have those vertical angles that are congruent and they have those inscribed angles intercepting the same arc that are congruent, what am I allowed to say about these triangles? They are similar, which means I could set up a proportion using these segments. However, in the interest of coming up with a property for these segments that looks a lot like the properties you're going to see regarding other segments, what will end up happening here is that the product of the parts of one chord will equal the product of the parts of the other chord. Put another way, J times K equals L times M. In plain old teenage speak, you might say part 1 times part 2 of a chord equals part 1 times part 2 of the other chord. Kind of out of space, but I hope that you get the idea. What you're doing is you're taking the two parts of the two chords, multiplying them together, and setting them equal to each other. And very frequently, there's a variable in there somewhere that we're trying to solve for. And hopefully this will kind of come together and make a little bit more sense once there's some numbers involved, if you're looking ahead at some of the problems like this diagram later on. Okay, so that's what happens when two chords intersect inside a circle. There's two different ways that segments involving a circle can intersect outside of a circle. I can either have, do we have what we need from the screen? I can either have two secants intersecting, as you see in this diagram on the left, or I can have a secant and a tangent intersecting, as we see in the diagram on the right. If you're thinking to yourself, but wait a minute, Mrs. Clouse, I could also have two tangents intersecting outside of the circle. But remember, we actually talked about that way back at the beginning of the chapter. Two tangents to a circle intersecting outside of a circle would be congruent. We talked about that earlier, right? But here, for the two secants intersecting, notice that I've given you the property in your notes that the external part times the whole secant will equal the external part times the whole secant. So if I put some variables into this diagram to kind of help gel things together, if this A is the external part of one secant and C is the whole secant, and this B is the external part of the other secant, where this D is the whole secant, the equation I could set up would be A times C equals B times D. And please adjust in your notes what it says for the tangent intersecting the secant. Where it says part, it should have said external part, just like with the secants intersecting. Oh, I saw it. Hopefully that's all the flicker we get. Because it's Florida. All right, so in the second diagram, you see a tangent intersecting with a secant, and the formula is given to you there. So if my tangent is T, and A is the external part of that secant, and B is the length of the whole thing, then I could say T squared equals A times B. Okay, so again, to summarize, two chords intersecting, part times part equals part times part. I can't think of an easier, clearer way to put that. If you've got one, I'd love to hear it. If I have a tangent intersecting with a secant, tangent squared will equal the external part of the secant times the whole secant. And then finally, if two secants intersect, external times whole equals external times whole. Once again, I get that these words may seem really weird and funny. Once we start plugging numbers in, I'm hoping it kind of comes together neatly. We have from this screen what we need. So in problem 3, part A, I've got 3 different things that can happen here. Two chords, two secants, or a secant and a tangent. What am I looking at in part A? I'm looking at two secants. So that's external times whole equals external times whole. What is the external segment for the top secant? The 12. What is the whole secant for that top secant? Careful, not 12x, 12 plus x. Okay, so that's external times whole for one of my secants. I do the same thing with the other secant. What is the external secant for the bottom secant? 11. And then what is the whole bottom secant? 11 plus 14, which is 25. And from here, this is just an algebra equation. You're solving for x. So 144 plus 12x equals 275. So 12x is 131. And that's going to give us some kind of decimal. 10.9. In part B, what am I looking at here? Two secants, two chords, or a secant and a tangent? The secant and a tangent. The property says I start by squaring that tangent, which is A. So A squared equals external part, which is 6, times whole secant, which is 15. Okay, so in your calculator, 6 times 15 is 90. And since A squared equals 90, you take the square root of both sides to get that A is 9.5. And there's a your turn, very much like it. Please take a moment within your group to work through those. Like I said, I will. For part A, you would have external times whole equals external times whole. Giving you that x is 13.75. Are we ready for the work shown for part B? Okay, the equation would be part times part equals part times part, giving you, rounded to the nearest 10, 3.2. And if If there's any work on the screen that you have a discrepancy with and you don't know why. Yes, ma'am. For part B, what we're looking at is the product of two parts. Try to say this again. The product of the parts of one chord will equal the product of the parts of the other chord. The parts of one chord are 6.5 and M, so I multiply them together. And the parts of the other chord are 3 and 7. Part of the issue with this diagram is it's kind of hard to tell in this upper right corner what's referring to what. So if that was the problem, perfectly understandable. Okay, so hopefully you saved yourself some space when I warned you that I had one extra problem that I want you to add because it's extra ugly, and I want to make sure that you're prepared for extra ugly in tonight's assignment. We have from this screen what we need. Okay, so I'm making this problem up on the fly because I don't want to have an opportunity to think too much about how to draw a diagram. Scratch that. I don't want the numbers working out pretty, to be honest. So I'm going to put, because that's just how mean old lady Clouse I am. Okay, so this is X and 11, and we're going to make this 13 and, I don't know, 8. Oh. Okay, so some of you might be thinking to yourself, well, what's so ugly about this? It looks a lot like one of our previous problems. Well, it's external times whole equals external times whole. In the top secant, my external part is X, and my whole secant is X plus 11. Are you seeing where this is going to get ugly? We'll end up with a quadratic when we distribute this. We'll have an X squared term and an X term. Ew, right. Some algebra that we need to refresh our memory on. Here we go. Let's finish this equation out, though. On the other side of the equation, I would have 8 times 21. And when I simplify this equation, as I said, we'll have a quadratic. X squared plus 11x equals 168. And I would hope that you'd remember from algebra, if you have a quadratic that also has an x term in it, if you want to bring everything over to one side of the equation, you must have a 0 in your equation. So I'm going to subtract the 168 from both sides, so that now I have my equation, x squared plus 11x minus 168 equals 0, and now my quadratic is in standard form. And I don't think that it does factor, but I'm going to pretend that I've exhausted all of my resources and I tried to figure out if it factors and it doesn't factor. Okay, so let's just pretend just in case it ends up working out nice and pretty in the end. If something doesn't factor, if a quadratic doesn't factor, the last resort that you have is the quadratic formula.
No, we did not. That is something I would remember.
Okay, if you didn't learn it last year in algebra, fret not. It's not something you're expected to memorize. It's on the reference sheet. Oh, don't say you'll never use it.
I said it's on the big things I've never looked at.
Oh, gotcha. But yeah, you can count on saying that again next year in Algebra 2 as well. Yay! Okay, so what you want to remember, and what is indicated, gentlemen and ladies, what's indicated on the reference sheet is what A, B, and C are out of this equation. A, B, and C are the coefficients of the terms in that equation. Remember, coefficients just means the number in front. Okay, so what is the number in front of the x squared term? Come on, what's the number in front of the x squared term? I think I heard it. It's 1, thank you, okay. What is the coefficient of the x term? 11, and then the constant, your c, is negative 168. So, granted, yes, that's big and ugly, but it's just a formula that you're plugging numbers into. Here we go. x equals the opposite of b, which is negative 11, plus or minus the square root of 11 squared minus 4 times 1 times negative 168, all over 2 times 1. That's one of the common mistakes that I see, is students just putting the radical over that 2a. I don't know why that happens, just letting you know that I've seen it happen. Please don't let it happen to you. So we plugged in, now we just simplify. I have negative 11 plus or minus the square root of 121 plus, do you see why it's plus? And negative 4 times negative 168. Negative times negative, remember, is a positive. I'm sorry? Good. Okay, let me give a moment of pause, because I'm seeing some deer in the headlights, and I don't know where the question is. So if you can articulate what the question is, I'd love to answer it. We just kind of... Fantastic question. The plus or minus indicates that every quadratic has 2 solutions. And in this instance, it'll be negative 11 plus or minus 28.16. Okay, so once again, let me address Maddie's question. Because of that plus or minus, I have 2 solutions for x. One of them is negative 11 plus 28.16 and then divided by 2. And the other one is negative 11 minus 28.16 divided by 2. And I'm waiting for it to occur to someone. I'm going to, well, no, the negative 11 doesn't have anything to do with the plus or minus. Think about what these 2 solutions are. Listen to what I described. I'm going to take this negative 11 plus 28.16 and then divide that by 2, and that's one possible value for x. And then I'm going to take that negative 11 and subtract 28.16 and divide that by 2, and that's another value for x. No, they're both going to be x. Say that again, I'm sorry? It's just calculator. Realize, what I'm wanting you to realize, ladies and gentlemen, is that one of those values is negative. Why is that a big deal? No, because, no, we're not seeing it. Where did this problem come from? Look at the... Exactly. We don't want x being a negative value because we can't have a negative length for a segment. So the only one that I'm interested in is the negative 11 plus 28.16, blah, blah, blah. So in your calculator, that's what you're typing in, is algebra. You're absolutely right. Okay, so x is 8.6 approximately. Right, 8.58, blah, 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 blah. Round to the nearest tenth, and we're at 8.5. Okay, so that's the ugly, nasty thing that I wanted to touch upon, ladies. Touching people. So that you're ready to tackle the homework assignment in the textbook. Tomorrow's a workbook day. Make sure you bring your workbooks. And I have a daily quiz on Socrative. Yes. Huh? Not on the daily quiz.